Good morning. It's Sunday today, and I am in chapter 6, 5, 6, and 7 in the part of dynamic. So today I am going to talk about drag force, which I know I already did it in the lecture on last week in the lab time. If you remember, drag force is a resistance force formed by air on the object. So imagine, guys, that if you have, for example, if you do have a car, okay, let's say this is a car, and drag force equation, it becomes 1/2 rho c a v square. So when a car or object or any particles, for example, let's say it goes to right direction, as we know, ladies and gentlemen, we do have friction force, which it forms between tires, between object and contact surface. So this is called FF. And in the same time, as object goes inside the air or inside fluid, like liquid, like inside the water, that makes resistance force. So inside the air, we do have drag force. So this forms by air. Okay, so drag force is actually a force against your motion. This is called Ft. So this Ft depends on, if you see here, density of gas, density of the air that we go through that. So rho is called density. And C, it's same as mu Fn. If you remember, friction force was mu Fn. So mu, it's called friction coefficient between object and contact surface. What is C? It's called drag coefficient. It's called drag coefficient. So it is same. We can find it actually in the labs. As we found value for mu, we can find also value for drag coefficient. What is A? It's contact surface area. It's contact surface area. So here, what is the contact surface area of the car? We can say it's all, of course, because your car is like square, correct? Or rectangle, let's say. Usually the width is 1.6 meters and height of the car is usually, for the normal cars, not SUV, for passenger driving car, is wide is like 1.6 to 1.7 average size, and 1.4 to 1.5 maximum is the height. So the area, contact surface area, is from the side. So this is the wide width of the car, and this is also height of the car, correct? So the area will be width times height, or length times width. And what is V? It's called speed of the car. Why do I call it speed? Because it's square, so it's the magnitude of velocity. So anyway, it is a speed. And the unit of force, drag force, is Newton, remember. So what is drag force? It is a force, opposite force. It's a force in opposite direction of motion formed by a gas or by air. For example, also we know that density of air it's 1.3 kilogram per meter cube. C, its drag coefficient, which is close to 1.1, and it doesn't have unit. So here rho is kilogram per meter cube. C is like friction coefficient, it doesn't have the unit. A is area, which it is square meter, correct? Rho is kilogram per meter cube, and force becomes what? Newton. It is important topic. So when a car actually goes on the highway, or when object falls from very high height, or skydiver actually he dropped himself from airplane, is doing free fall, or rain droplet when they fall, actually when they get released from the cloud, they are affected by drag force. Okay, so if we move inside the air, we have drag force 100% against our motion. So one car, when it moves, when it rolls, one tire, one wheel, one bicycle, when it rolls on the surface area, so what we have two opposition forces. One is friction force, the other one is drag force. Okay, let's do one example. Example says this: a passenger car has 1500 kilogram mass. So I'm talking about average mass of the passenger car, which it is between 1400 to depends 1700, 1800 kilogram. So it's not by pound, it's by kilogram. Its mass, its weight. So let's say we do have this is the surface area that it contacts with the air. As it says, let's say the width is 1.6 meter and its height is 1.4 meter, for example. Okay, the average size. Aerodynamic body shape gives drag coefficient, so C becomes equal with 0.35. As I said, it's like friction coefficient. At what speed magnitude of drag force, pay attention here, at what speed magnitude of drag force, so it says at what speed, we must be what? To have magnitude of drag force, so Fd becomes equal with what? Rolling friction force becomes equal with friction force. So this is our goal, that we want to find at what speed drag force is equal with our friction force. So what we have, ladies and gentlemen, look, imagine this is again, let's say it's a car, right? And this car goes to this direction, which is positive direction. So let's verify forces. As you know, always, we do have, of course, one force is pulling or pushing force. So this is called propulsion force or engine force. So I call it by FP. FP means is pulling or pushing force, or propulsion force. The second force that we have always and always remember, it's mg, force of weight. It's downward, it is perpendicular on the ground or on the earth. The next force, always you have it guys, it is Fn, normal surface force, which it is force formed by the surface on the object. And here, now let me make different colors. Here we are going to have also friction force, it's in opposite, and plus a force formed by air, which it is Ft. It's against your motion. So here what I see, if I say this is x, this is y-axis, on the x-axis actually I am going to have a propulsion force, correct? So this is called free body diagram. Then here I have also friction force, correct? Then on x-axis also I do have what? Drag force. What do I have on y-axis? I do have Fn, which it is upward, and also here I have what? Mg. So far makes sense? Okay. Now, question is this: at what velocity, at what speed drag force is equal with friction force? So let's do solution. So remember, we have to find friction force always first. So what is friction force, guys? We have to write sigma F equal 0 for the axis that there is no motion. There is no motion on y-axis, therefore very simple, we can say Fn minus mg is equal with 0. So finally Fn is equal with mg, and therefore we can say friction force is equal with, oops, sorry, why does this happen? Friction force is equal with, oh my goodness, come on, really, mu mg. So this is our friction force, which if I substitute will be let me see how much is friction force, 0.02 0.02 times mass of the car is 1500 times 9.8. The answer becomes equal with 0.02 times 1500 times 9.8 equal 0.02 times 1500 times 9.8. Answer is, what is that? 294 newtons. This is your friction force. This is friction force. Okay, now remember what we have now on x-axis. On x-axis, because we do have, of course, acceleration. So we are going to have propulsion force minus Ft and minus Ff equal ma. Correct? Now here question says, at what speed friction force becomes equal with drag force? So for that reason, acceleration must be 0. That means as your car must go with constant velocity. Therefore, if we have that, so propulsion force becomes equal with 0. So Fd is equal with what? Ff. Okay. So It says at what speed Ft is equal with Ff, drag force is same with friction force. Therefore, if I substitute friction drag force, sorry, so I'm going to have 1/2 rho C A V square is equal with friction force is mu mg. So they want me to find speed. So let's solve it for speed. Speed becomes equal with 2 mu mg divided by 2 mu mg divided by rho Ca, and of course we have to take square root. Okay, so this is our speed. At what speed your drag force is same with friction force. Now that is equation, so if I substitute, V becomes equal with radical 2 times, we already found mu mg here, it's 294, which it is here already, correct? Divided by rho for air, it will be given, it is 1.3. C is given actually, how much was C? 0.35 in the problem, you have it 0.35. And what is A, guys? Look, area is 1.6 times 1.4 will be square meter. So if I do that, so if I write 1.6 times 1.4, correct? And let's do calculations. 2 times 294 divided by 1.3 divided by 0.35 divided by 1.6 divided by 1.4, then take square root of the answer, so it comes 24 meters per second, 24.01. Therefore, 24 meters per second. So remember, if you do have Toyota Camry, Honda Accord, usually they are in between 1400 to 1600. BMW is a little heavier, like 17 to 1800 kilograms. So imagine if we have those kind of cars, when your speed is 24 meters per second, your drag force is equal with friction force. So if I find it by miles per hour, it becomes 24 times divided by 1609, correct? Yeah, let me see. We do this 24 meters per second times meter, then I'm going to have miles here, then I'm going to have hour here, second here, so 1 hour is 3600, 1 mile is 1609, correct? So the answer becomes 24 times 3600 divided by 24 times 3600 divided by 1609. Yeah, almost 54 miles. Okay. So guys, ladies and gentlemen, if you go with 54 miles per hour, in that time, usually depends on the concrete, depends on asphalt, depends on friction coefficient. when you go with 54 miles per hour, your drag speed becomes equal with friction force. Hope you liked it, and please practice it to see what's going on. All right, so we went over drag force. This is the example that we did it, and here is solution. Now, let's talk about terminal speed. What is the terminal speed? Watch, guys. Imagine here is the planet Earth. Now, and let's say the clouds are here. Okay. Water droplets, they start to falling. When they fall at the beginning, of course, they accelerate. So speed increases because free fall is free fall. Free fall is motion with acceleration, and acceleration of falling, as you know, in free fall is g, which it is 9.8 meters per second square. Excuse me. So when object falls, after elapsing of time and after traveling some height, and some time, this object at a certain of time, what is happening, we do have mg when object falls. It's because of mg, and in the same time, remember, here is air, and this air makes drag force on the object, correct? And drag force is in opposite direction of motion, because your falling direction is downward, so mg is in the same direction as falling direction, and drag force is in opposite direction of your motion. Okay, so at a certain time and certain height, guys, so speed increases, then what is happening? Drag force becomes equal with mg. So at certain height and certain time after, object gets released, after water droplets gets released from the cloud, after certain time, certain height, your drag force becomes equal with what? Force of weight. Okay? Then after that, object moves with constant acceleration, no, with constant velocity. Remember, v becomes equal with constant, so your acceleration is 0. So please do not say it falls or it goes by constant acceleration. If it goes by constant acceleration, so it's free fall, it's motion with acceleration. But what is happening after elapsing time and height, velocity becomes constant. So when velocity becomes constant, your acceleration is 0. Okay, that's why Fd becomes equal with Fw. In reality, it's Fd minus Fw equal m times 0, correct? Therefore, Fd becomes equal with what? Fw. Now, if I work on this, Fd, as we saw last week, and also in this equation, that if D is equal 1/2 rho CA V square, so let's write 1/2 rho CA and V square equal force of weight, which it is mg. Now guys, we can solve this equation actually for velocity, for speed. If I solve this equation for speed, V becomes what? Here I have 2 mg, correct? 2 mg divided by rho CA, am I right? And then if I take what? Square root. This velocity, we call it Vt, or let me write Te, and write is okay, R. That means is terminal velocity. It's terminal what? Speed or velocity, but I have to say it is speed. Why? Because it's magnitude. It doesn't matter if we say terminal velocity. So what is terminal speed for object? It's 2 mg divided rho CA, take square root. So here what I see. What I see here, guys, I can actually conclude important thing here. Guys, if mass increases, here I see the terminal speed also what? Increases. So that means terminal speed of object depends on how heavy is the object or how lighter is. So heavier object, they will have more terminal speed than the lighter object. I can tell you one example that it says this. A 10 centimeter diameter lead ball with mass of 6 kilograms has a terminal speed of 160 meters per second, while a 10 centimeter diameter styrofoam ball with mass of 50 grams has terminal velocity of 15 meters per second. So a 6 kilogram, same area lead ball. Imagine you have a basketball which is made not by plastic, it's made by lead. And let's say diameter is 10 centimeter and mass is 6 kilogram. In your other hand, you do have same area ball, but at this time you made it by styrofoam, which is light object. You drop them in the same time, okay? They will fall with the same acceleration, of course, but after a while, they will reach to terminal velocity, each one at different time, at different height, okay? The terminal velocity of heavier ball, which is lead ball, it's 160 meters per second, and styrofoam ball, which it has 50 grams, it is 15 meters per second. So terminal velocity depends on mass. Terminal velocity also depends on area. So if you have larger area, if area increases, what is happening for terminal velocity? Decreases. So if we have larger area, then of course we will fall when we reach to terminal velocity. After we reaching to terminal velocity, if we have larger area, terminal velocity will be much less than if we have less area. Okay, so let's do one example. Question says, find terminal speed of skydiver. So usually, guys, skydiver, let's say mass is 75 kilogram. So you may say, what is 75 kilogram? Usually the average mass of human, this goes by average, it's 75 kilogram. So let's see what can I do. So guys, imagine this is a person, okay, which he is in the air and he dropped himself already. So after a while, after like elapsing time t, and also after traveling height of h, this person will reach to terminal velocity. So question is this: find terminal speed of skydiver. Mass of person is 75 kilogram. The c for air, which it is air coefficient, drag coefficient is 1.1. Density of air is 1.3. Now we need to know also what? The size of object. So guys, again, average size of one person, human, is 1.8 meter. It's his height. And his width, it's like 40 to 45 centimeter, 50 centimeter. Let's go with 40 centimeter, which it is 0.4 meter. Okay, now if I go over terminal velocity equation, I can write Vt is radical 2mg divided by rho Ca. Okay, now if I substitute these values, V for terminal, so remember this is not tangent velocity, do not be confused about Vt and that Vt that we will have it in chapter 8. So it's radical 2, his mass is 75, G is 9.8, rho is 1.3, C is 1.1, and his area will be 1.8 times 1, times 0.4. Okay, so I'm going to take square root of this value. Let me see, what is that? 2 times 75 times 9.8. So I want you, please, also you do calculation with me. So assume and imagine which it is the real class. So guys, please put your time, spend your time, study. Don't say it's online. So the answer becomes equal with 38 meters per second. So please practice, okay? You need to learn. Spend your time, guys. Don't say we do have video, so I'm gonna watch this video later, or it's easy. No, you have to take the note in the same time as I do lecture for you. You have to practice. You have to do calculations at the same time that you do. So I want you to write all of these in your physics notes. You need it. You need it. you need it for your future in physics 4B, in physics 4C, when you go to university, when you take the more engineering classes, you need all of these guys. So please have them in your notes. Okay. So this is about terminal velocity. I hope you liked it. It's really enjoyable. So one skydiver, when he drops himself after spending time and after elapsing some distance, finally his speed reaches to 38 meters per second, and again after that will start to increases when it gets more closer to the planet Earth. So guys, one important thing, you do have some problems in chapter 6, as I know. It's about drag force, which over there you can find like how many minutes later or second, how many minutes or how many seconds later this object reaches to terminal velocity, or after how many meters, after how length, after how distance object travels, then reaches to terminal velocity. So please work on those problems. It's in chapter 6 about drag force. Okay, so the next topic. uh, some students, they emailed me and they asked me to go over this problem. I don't remember exactly what masses did I give you. So I wrote 5 kilogram is mass 1, M2 is 3 kilogram, and M3 is 1 kilogram. So we have 3 masses, and these 3 masses, they are connected by one massless rod. Okay, so these are massless rods. And let's say also mu k, I think I gave you 0.3 or 0.2, I don't remember exactly. Let's go with 0.3. So question was actually this, that below figure, what is that below figure? Find tension, correct, on massless rod between objects. It's very hard to write on this screen touch, honestly, but it's okay. We will go over it. So what we need to do, remember always, you need to verify direction of motion. Okay, I am going to do it by this red color. So here is positive direction, which it goes, object goes to the right. Okay, then of course our coordinate system will be like this, correct? This is X and this will be Y. Now very quickly, let's verify forces. So I go with blue color here. Let's verify them, guys. But always, oops, what is this? I don't know. Okay, let's see. Always the first force. What is the first force? That's so bad. So M1 is 5 kilogram. Okay. The first force, mg, m1g. Second force, what is that? Fn1, correct? Then also we have friction force, ff1. Am I right? Then what do we have, guys? For m2, We do have one tension here. I call it T1. For any action, there is reaction equal opposite. So this is T1 too. Correct? So this is T1 also. That's T1. Guys, this T1 pulls M2 to the right direction. This T1 doesn't let M1 goes easy. Why? Because this T1 forms by M2. This T1 forms by M1. So one more time. This T1, which it's caused to move M2, it forms by M1. This T1, it forms by M2. It doesn't let M1 moves easy. They are equal. So this T1, the left one belongs on M2. This T1, the right one, belongs on M1. Okay? Same thing here, guys. This is M2G. Put this one like this. And here what I have, Fn2, correct? And then here what I have friction force 2, correct? Same thing, I have T2. Same thing here, I have T2. Then I have friction force here, FF3. Then I have M3G here. Oh, come on. Not correct? Then here I have Fn3, right? Now, now guys, remember what we have. Let me go by green color. We do have pulling force. Actually, it makes what it makes angle. Therefore, we are going to have components. So remember, from force of F, you need to go down on x-axis. So this will be F1 cosine 10, correct? And in the same time, this will be what? F1 sine 10. Okay? Here also, I am going to have F2 cosine 15. And also, remember, I am going to have F2 sine 15. Now, there is one important thing that you have to pay attention here. Watch it, guys. Your force of F1 pulls the object up. So the components, these two components, one on X, one on Y, they have to be in the same direction as your forces. So if your force is that direction, your component must be also in the same direction. That's why this arrow, the green one, must match with the arrow of this black arrow of force of F1. Now look at here. F2 pushes the object, correct? So how is your components the arrow on the force must match with the component, or component arrow must match with that force. So let me tell you here. Look, guys, imagine this is your x-axis, correct? This is your y-axis. So far, therefore, remember, if this is F, here you have component, correct? So this will be F, let's say this is the angle theta, F cosine theta, and this one is what? F sine theta. Now, if I have y-axis, x-axis, something like this, correct? Watch, I push it. So here your force is down. Therefore, my components will be like this. Pay attention. Look at this arrow, look at this arrow. They have to be in the same direction. So this will be F cosine theta. This will be what? F sine theta. Do not forget this, please. Okay? Yes. So let's do solution actually. So we have to find friction force first. So I'm gonna write sigma F equal 0, correct? So we know FF is mu Fn. So I have to work on Fn for each mass, correct? For each mass. So let's do it for M1. Watch it, guys. M1 on y-axis, I do have three forces. One is this blue one, which is Fn1. One is F1 sine 10. Green one is M1G, which it is force of weight. Therefore, what I am going to have actually now, so I'm gonna write Fn1 plus F1 sine 10, correct, minus M1G equal 0. So finally, Fn1 becomes Mg, which is M1G, minus F1 sine 10, correct? Therefore, friction force F1 will be mu, pay attention, you have to open parenthesis and write all Fn inside parentheses. So this is 10, correct? Now if I substitute the numbers, let me see, what is that? 0.3 times parenthesis, M1 is 5 times 9.8 minus F1 is 100 sine 10. Correct? So I got 9.49 meters, newtons. Correct? So this is friction force for object 1. What do we have for object 2? For M2, I am going to have Fn2 minus M2g equals 0. Therefore, my friction force for object 2, Fn2 becomes equal with M2g. It will be mu M2g. If I substitute, it's 0.3 times 3 times 9.8. The answer is 8.82. 8.82 newtons. What about for M3? For M3 is, if you take a look, guys, watch it please. How many forces do I have on y-axis here? On y-axis, I do have M3g down, Fn3 up, and F2 sine of 15 down. So I am going to have Fn3, correct, minus F3 sine, what is that angle? 15, correct? Minus mg equals 0. So I want you to pay attention between 1 and 3. Therefore here, I can find Fn3. Fn3 becomes equal with, this is M3g. M3g plus F3 sine 10. Therefore, friction force 3 will be mu times this guy, M3g plus F3 sine 10. Look, I want you to compare friction force 1 with friction force 3. In friction force 1, you have mg minus that F sine 10. In third one, you have mg plus. So guys, for part 1, when you pull the object up, you actually decrease friction force. So what you do, you decrease that pulling or pushing downward force. So you decrease pushing downward force. You increase, you increase this distance. You remove that sticky part. So that's why you decrease friction force. But in third one, in M3, okay, in M3, what we do, excuse me, like long moving machine, we push the object. When you push the object, of course, you increase that sticky section contact surface. So in F3, in M3, your pushing downward force increases. That's why friction force increases. Remember, when you move your grasses, your lawn machine, you actually need more force to move it forward, correct? Why? Because of this plus. So you increase friction force. Now if we substitute, let me see how much is that. Okay, what is M3g? M3 is 1 times 9.8 plus 30 times sine. This should be 15, correct? this should be 15, I'm sorry, because 10 is the other one. Yes. Okay. So sine 15 times 0.3, 5.26. Is that correct? Let me redo it. 9.8 plus F3 was 30 sine of 15 times 0.3. Yeah, okay. So this is this. Now what I have, let me erase this. Let's continue that. The same page. Okay. Now guys, let's write sigma f equal ma for the axis that we have motion. So I am going right for m1, m2, m3. All right, let's do it together. What we have for m1 on x-axis, just cover m2, m3, everything. So let's go only on x-axis for m1. I have f1 cosine theta 10 minus t1 minus ff3. So I have f1 cosine 10 minus t1 minus ff1 equal m1a, correct? This is 10. What I have for m2, I have t1, t2, and ff2, correct? So I have t1 minus t2 minus ff2 equal m2a. What I have for m3, I have t2 plus f2 cosine of 15, because f2 cosine 15 is in the same direction as direction of motion is, red one. So t2 plus f2 cosine of 15 minus ff3. So t2 plus f2 cosine of 15 minus ff3 equal m3a. Now watch it. This t1 with this t1, see you later. This t2 with this t2 gone. So my equations is correct. Therefore, I am going to have f cosine of 10, correct? Plus, of course, this is f1. f2 cosine of 15 minus all friction force. I can factor with minus, but let's do not yet. Okay. Come on. ff1 minus ff2 minus ff3 equal, you can factor with acceleration. There you go. Now you have to substitute to find acceleration. That is your job, honestly. You have to do that. But let me see, maybe I can do it for you, no problem. So how much is f1? 100 cosine of 10. How much was f2? 30 cosine of 15 minus, what is friction force? 9.49 minus 8.82 minus 5.26 divided by total masses is 5 plus 3 plus 1, 9, correct? So I got, come on, acceleration is 11.54 meters per second square, correct? Now guys, we want to find tension 1 and tension 2. So here I can say T1 is 100 cosine 10, correct? Minus friction force, how much was friction force 1? 9.49 minus 5 times 11.54. There you go. I got 31.29. 31.29 newtons. That's T1. Now it's up to you. You can substitute T1 in equation 2 or 3 and then find T2. I go with the second one, so I can say T2 is, what is that? 31.29 minus friction force 2 is 8.82, correct? Minus, how much was N2? 3. 3 times 11.54. The answer becomes equal with 12.15. Is that right? Anyway, you do it again and let me know. So important is to finding actually this equation, which is called force equation. Important is finding these equations for friction force for each mass. You know, you have to know these, remember. And then the calculations is with you. Okay? So guys, as a practice, I am going to give you one example. So I want you to do it. I'll give you a due date for that now. So the question is this. Let's say we have a surface, okay? And let's say we have 3 masses. Oops, what is this? Don't understand. Okay. Come on. Let's say we have here M1 is okay, 5 kilogram. M2 is 3 kilogram and M3 is 1 kilogram. Okay, so M1 is 5 kilogram, M2 is 3 kilogram, M3 is 1 kilogram. And friction force, kinetic friction force is, choose it as is 0.3. Okay, and also we apply a force of 60 newtons, and let's say this angle is 10 degrees. Question is this: below figure, find force between masses. Okay, due date for this problem is tomorrow is Monday. Today is March 22nd, 03 23 20. Before your class is at 2 o'clock, two p.m. I want you to do it to see, are you really working on the problems? Are you watching these videos, or you just pass the time with no reason? So please, this is due date for tomorrow. Do it. Verify forces, everything, and post it to me in the Canvas. Okay, post it to me, each course in Canvas, and also start to work on problems chapter 6 and 7 from your syllabus. Make sense? So chapter 6 and 7, start to work on them. Do this problem for tomorrow. Today is Sunday, so I don't want to push you at this time. But tomorrow before 2 o'clock, you have to send it to me. Please watch these videos, study, so I can tell you I'm done almost with chapter 6 and 7. Hopefully, I will start it very soon from tomorrow, chapter 8, and I will finish this. I got some emails that most students, they like to do lecture on Screencast-O-Matic, on screen, touch screen, on the laptop or on your tablet. And also some students, just a couple of them, they asked that writing on whiteboard is easy to catch it. Of course, writing on whiteboard is easy for me also, because you see sometimes this pen doesn't work, or some problems. I don't promise you whiteboard at this time, because maybe, light problems. Sometime, because I record all my lectures by my camera, by my phone. So that makes some different problems. So far this works, so let's see how it goes, okay? So just please study, guys. Be very serious. Be very serious. assume and imagine that you are in the school and you have to do your homeworks, okay? So have a good day. Today is March 22nd. It's Sunday. Have a good Sunday, good afternoon, actually, good evening, and please study, okay? See you later. And also, tomorrow we do have office hours after 3:30. So I will invite you by Zoom at 3:30. So please check your emails, okay? Bye, guys. Bye. Let me see this one. What is this? No, wait. So where is this? Screen Customatic. What is that?